So we're going to talk about the ls command, but before I do that I want to take a little bit of a diversion here because something that kind of comes up and it's a little bit confusing sometimes. And that is the alias command. So normally we do ls and we hit return and we take a look and we have some files here in this directory. If I do, and I notice that two of those files, one of them is in blue and one of them is in green, the rest of them are in white. If I type alias ls and I hit return, I look, it says ls dash dash color equals auto. And what that does is that the alias sets the ls command to ls dash dash color equals auto. What that means is that when I type ls, it expands it out to ls dash dash color equals auto. So one way around that, if I want to run the ls command without having it expand that alias, I can just use the backslash. So I say backslash ls. Now you'll notice that those two files that were in color before are just plain now. And that's because it's just the ls command, not ls dash dash color equals auto. Now there's a way to take that feature off and say unalias ls. And now when I type ls or backslash ls, I get the same exact result. Now I can put that back and I can say ls dash dash color equals auto, alias I should say, alias, ls dash dash color equals auto. Now when I type ls again, it's been aliased to ls dash dash color equals auto. Alias ls, and there you go. So that's something that's kind of confusing because a lot of commands in Unix are actually being alias to something else, and you can find out by typing which, W-H-I-C-H, which ls, and that's going to tell me which ls is actually executing. And if you take a look, you can see that it's alias to that. So something that was confusing, hopefully that straightened it out. Now let's get into directory listings. So when I say ls, it just gives me a directory listing, and it gives it to me in roughly alphabetical order, as you can see. Starts up with a C and ends up with a W, so that looks about right. Now there's another way to look at directories, and that's using the long listing, and that gives you a lot more information. So I say ls-l. Now I take a look at this, and I look at the very first file here, CPU suck, and the first thing I see is this dash. The dash just means that it's a regular file. If I come down here to temp, temp is a directory, and so there's a D in that place. There's some other symbols that will be used here as well, and that's in another video. But for the time being, we'll just look at the dashes and the D's. We can see that the D is for a directory, the dash is for a regular file. Now the next thing we have are the permissions, and the permissions, there are 3 permissions for each file, and they come in 3 different groups. And the first group is the owner of the file. And the owner of the file, if I type ID here, the owner, my user ID is 505 is the number, and our brain is the text of that particular user ID. Also, I guess I'll go ahead and explain the group ID. You belong to a particular group. Sometimes the group is the same as the user. In this case, I've created a group called developer, and the developer contains the user, our brain. That group could contain 1 or 2 or 100 other developers. There are lots of groups in Unix, and they're used for various things. So the first 3 are the permissions for the owner of the file. In this case, I have read permission, I have write permission, and I have execute permission on that file. The second group is for the group, and that's for the developer. Anybody who belongs to the group developer has these permissions. They have read permission, they have execute, but they don't have write permission to this file. The last group is for anybody who's not the owner and is not in the group, and that's the rest of the world. And the rest of the world has read permission and execute permission for that file. So again, 3 different groups of lettering, RWX, read, write, and execute. Those are the privileges for the file. And the first group is for the owner of the file, the second is for the group of the file, and the third is for the rest of the world. The one here is for the number of links to the file, and I'll get into that in a minute. Next is the owner of the file, which is me, our brain. The third is the group, the next one is the developer, the group of the file. This is the number of bytes, 4,729. That's how many bytes this file takes up. And then we have the creation date, or actually the last update date and the update time. And then of course the name of the file. So moving down here, we look at cpusuck.c. We can see that it's got 53 bytes in it, and lorem ipsum has 447 bytes, etc. on down. Directories are kind of a special, but they're typically in multiples of 1,024. So that's why 4,096 here. So that's the ls-l command. Also, I can do an ls-a. And what that does is it shows hidden files as well as my regular files. And you notice that I have a special file, a hidden file here. And so this is a special file, and it just represents the current directory. The dot represents the current directory. The dot dot represents the directory above this one. So for instance, if I do a cd dot dot, that takes me up to the directory above the one that I was just in. Again, if I do cd src, that takes me back to where I was, ls-al, ls-a, and again I can see my files that are hidden. Dot and dot dot are special cases. I also have dot don't look and dot hidden, and I can see those up here in this long listing as well. You can mix these commands, ls-a, you can do an ls-l, you can do an ls-al. Usually works. Okay, next is ls-m, and what that does is it takes the files and it separates them by commas. Just a nice feature when we get into redirection and whatnot, that'll come in handy. ls-f, that will append a special character to all the files depending on the type of file. You notice that now cpusuck has an asterisk after it, so executable files have asterisks after them, and directories, for instance, have slashes. They're all different types of files, and you can look through the ls command manual page and find out what all the special characters are. You can also do an ls-r, and I'm going to combine that with the long command, so ls-rl. And what it does is it reverses the order of the files. So if I do ls-l, I notice that cpusuck alphabetically comes before all the rest of the files. If I do an ls-lr, it reverses the order. I can do an ls-t, and that will list the files in order of the time that it was modified. So if I do an ls-lt, I'll notice that everything is in time order now. So very common to do an ls-lrt, because what that does is it lists this is the most commonly modified, this is the most recently modified file and going backwards in time. So this file words hasn't been modified since the 16th at 509. So those are very common usages. There's also the capital R, ls-lrt, and what that does is it lists everything in recursive fashion. So it's actually going into the other directories that are below this one. Right here in the current directory that we're in, it lists all the files in time order. And then here we're actually going down into the next directory, temp, below the one that we're currently in, and we're listing all those files as well. There's also inodes are associated with files, and when you create a file in Unix, the operating system will assign an inode to that file. So if I say ls-i, let me do ls-li, long listing. This is the inode for that particular file, and it is 588874. That's a unique number to that file. Every file in Unix gets a unique number. And inodes are pretty interesting. There's one other thing that I want to bring out here to show about linking using the ln command to link files. There's two types of links. There's a hard link and a soft link. And using the inode to explain it is pretty powerful. So again, this CPU suck inode is 588874. Now what I'm going to do is I'm going to create a hard link. So I'm going to say ln CPU suck, and I'm going to call it CPU link. Now if I do an ls-il, ls-il, and I take a look here, I notice that CPU link and CPU suck, they have exactly the same inode. The reason that they do is because it's the identical same file. If I type CPU link or CPU suck, either one, it's going to execute that exact same file. The other thing that I kind of glossed over was the number of links to a particular file, and if you take a look here, you'll notice that it's 2. The CPU link has 2 files associated with it, 2 file names associated with that one inode. And I can go ahead and I'll create CPU link 1. I'll do another link just to show what happens here. Now we have 3 links to that exact same file. The inode's the same for all 3. There are 3 links, and there are 3 names to the same file. You'll notice that everything else is identical about them. So now what I can do is I can say remove CPU link and ls-li, take a look, and I notice that my count is down to 2 because I just deleted, and I still have those 2 files here. I'm going to go ahead and I'm going to remove the last one, the CPU link 1, ls-li, and now I'm down to 1. I only have 1 link. Now if I were to delete that, that would be it. That would be the end of the file. It would no longer exist. Unix file system is very difficult to get files back. Depends on your file system, but typically you can pretty much write it off. It's probably going to be gone. The other type of link is called a soft link, and so I'm going to type ln-s CPU suck and CPU suck soft link. And I'm going to do an ls-li again, and what we notice here is that I have this other file, CPU suck soft link, but I look at over here and I have a different inode. The inode is completely different than the CPU suck file, and that's because it actually created a brand new file on this this file system. And if you look here and you look at the number of characters, there's 7. The reason there's a number of 7 because this file contains the text CPU suck. So it lists the number of characters, and it's just a soft link. It doesn't change the number of inodes. And there's a reason for using soft link, and there's a reason for using a hard link, which we're not going to get into here, but something very handy to have. So if I type CPU suck and let it run, all it does is it's just a while one loop, and it just loops forever until I do something. I'll type Control C, gets rid of it. Again, if I do CPU suck I need to use the dot there. The dot means use the current directory first. Okay, CPU suck soft link, and again I'm just running that same file, the CPU suck, using the soft link, and again I use Control C to get out of there. So ls-lrt, there's all of our stuff again, and I'm going to remove CPU suck soft link and do ls-lrt again, and we're back to where we were. So that's a pretty good overview of Unix directories, and that's it for now. We'll see you on the next video.